All right, this problem wants us to find another linearization, but then once we have that, they want us to approximate two other numbers with our linearization function and see if these approximations end up being overestimates or underestimates. So first off, again, if we're going to find this linearization, we're going to need to find both the point and the slope of this one. Let's start with the point. We know our x value is 1 because they say a equals 1. What's the y value? To get that, we can plug in 1 for x and see what this ends up being. So we end up with square root of 4, which is 2. So our point is 1, 2. For our slope, we're going to need derivative. So what is the derivative of our function here? I'm going to first write this out as power of 1/2 instead of square root before we find our derivative. So now we're going to use chain rule here to find this one. So bring down the half, leave the inside alone. New function, or new power is negative 1/2 times the derivative of the inside, which ends up being just 1 here. All right, so now what is that going to be at 1? What's the slope right at 1 here? I'm going to first rewrite this a little bit better here. So this would be 1 over 2, and then negative 1/2 is the same as square root in the denominator of x plus 3. So what is this slope at 1? That's going to be this. Square root of 1 plus 3, or square root of 4, is 2. And so on the bottom here, we got 2 times 2, or 4. So our slope is 1/4. So now our linearization function would be y minus 2 equals our slope, x minus 1. To simplify that, we can distribute there. Now add 2 to the other side. When I add 2 here, I'm going to add that as 8 over 4, so I can combine it with the negative 1/4 there, because 8 over 4 is the same as 2. So now we get that y equals 1/4 x, and then this would be plus 7/4. So that's our linearization function now. All right, so we got that. All right, next now, they want us to approximate it at 2 points, 3.98 and 4.05. So what would those be? Now remember, this linearization function here is occurring at 1. So what this function is this linearization is a good approximation of the function f of x equals square root x plus 3, but only around x equals 1. If we're near 1, it's a good approximation. The further we get away from 1, it doesn't end up being as good of 1. So it's only, so around 1, around x equals 1, there, what we're saying here is that square root of x plus 3 is very close to 1/4 x plus 7/4. So that's what our approximations say. So now we want to figure out what's that value around 1 that we would want to use to approximate these two up here. So let's start with this one. What if we're going to approximate 3.98? What would be the x value we'd want to put in there to do that? Well, it's whatever x is plus 3. So if we have x be 0.98 and add that to 3, that would end up being 3.98. So that's the x value we would want to use to approximate this out. So our linearization here, if we're going to approximate, what we're going to use an x of 0.98. That means this ends up being 0.98 plus 3 or 3.98, that should approximately then be equal to our linearization here when we plug in the same value of 0.98. So now let's use calculator and see what we get from that. So on your calculator, do 1/4 or 0.25 times 0.98, and then add on the 7/4. And this tells us this is approximately equal to 1.995. Okay, let's do the same thing now. The other one they want us to approximate, if we go back up here, other one they want us to do is 0.405. So what would x need to be for that one? Well, again, we're adding it to 3. So if we subtract 3, it looks like x would have to be 1.05, because that plus 3 would be 4.05. So to do our other approximation, we're going to let x equal 1.05, because then if we add that to 3, that's going to be square root of 4.05. And that should approximately be equal to now our linearization at 1.05. So do the same thing, use your calculator to figure this one out. So multiply it to 1/4 and add 7/4, and it looks like this one is going to be about 0.0125. Now the last part of this, they want us to know, are these two estimates overestimates or underestimates? So a good thing to do here would be to graph out both of them and see if it's going to be overestimate or underestimate. So on your calculator, let's type both these in. So go to your graph or graphing part, and let's type both of these functions in and graph them. So one, we're going to graph square root of x plus 3, and the other one we're going to graph is our 1/4 x. I'm going to type it in as 0.25, which is the same thing, x plus 7/4. All right, so if we graph this, and I'm going to use, let's try it on the decimal one. I think that'll give us a pretty good graph. All right, so there's our curved one. There's our linear approximation. We can see from that, it looks like our linear approximation always ends up being over our actual graph there of x plus 3. So at our value of 1.05, maybe that's right around, let's say it's right about there, it looks like our estimate is going to be a little bit of an overestimate. Even our other one of 0.98, that should also be a little bit over the actual value there in blue. So both of these, we would say both of these here are overestimates. Oops, try that again. Both of these would be overestimates because tangent line is over the graph. It is. It's above the graph of f of x. So both of them would be overestimates. So that's how you can use tangent lines to approximate the value. It's not going to be exact, but it'll give you roughly what that value should be at that spot.